Hi everyone, welcome to Systematic Automation. I hope you all are doing well. In this video, we'll see how to do a simple program for basic water level system. So first I will open Factory IO. This is the setup I have created in the Factory IO. In this we are having start push button, stop push button, a water tank, a low level sensor, a high level sensor, an inlet wall and an outlet wall. So the conditions are whenever I press start push button, the inlet valve should turn on and water starts filling in the water tank. As the water level reaches the high level sensor, inlet valve should turn off and the outlet valve should turn on. As the water level reaches the low level sensor, outlet valve should turn off and the inlet valve should turn on. The process should continue until you press stop push button. For this setup, we will do programming in the TIA portal and verify the output in the Factory IO. So let me open the TIA portal. In the previous video, I have explained how to add the factory over template and how to upgrade the file. In this project, we are having 1211C DC PLC. We'll go into the program blocks and I will go into the main OB. So this network 1 FC9000 block is the main reason which is used to communicate between TIA portal and factory IO software. I will start the programming from network 2. I will take one NO, one NC, one output coil and I will open the branch from here. I will take one NO and I will close the branch. I will give address for this as I0.0, for this as I0.1. I will store the data into the memory M0.0 and I will add the memory here. I will rename this as start push button and I will rename this as stop push button and I will rename this as system memory. So I will minimize this. In the network 3, I will take NO, NC output and I will open the branch from here. I will take one NO and I will close the branch. I will address this as I0.1, this as I0.0, this as M0.1 and I will add the memory here. Means I will store the push buttons data into separate memories. I will rename this as system of memory. Okay. In the network 4, I will take one NO, NC, NC and output coil. I will open the branch from here. I will take one NO and I will close the branch. And I will open the branch from here. I will take one NO and I will close the branch. I will give address as I0 M0.0, for this as M0.1, this as Q0.1 and this as Q0.0. Means my inlet wall should on when the system memory is on. I'll give this as inlet wall and inlet wall should off when the system memory is off and the outlet wall is on. This is outlet wall. This I will latch here Q0.0 and inlet wall should turn on when I0.2. It is a low level sensor. I will rename this as low level sensor. Okay. Means inlet wall should turn on when system memory is on and it should latch here, and inlet wall should turn on when low level sensor is high. Inlet wall should turn off when outlet wall is on or system off memory is on. So in the network 5, I will take one NO one NO, one NC, the output coil. I will open the branch from here. I will take one NO and I will close the branch. For this, I will rename it. I will address as I0.3 and I will rename this as high level SOR. Okay, high level sensor, and this as I0.2, which is low level sensor. It should off when system off memory is on, and I will store the high level sensor data into a memory em0.2, and I will address this as em0.2. This will be outlet wall memory. Means outlet wall memory should on when the high level sensor is high, and it should latch here, and it should turn off when the system off memory is on. So from this memory I will turn on an output m0.2 and this as q0.1. Okay, this is what the program we have written. So currently I'm not using actual PLC, so therefore I will do start simulation from here. As you press start simulation button, so a message will appear here: starting simulation will disable all other online interfaces. So just press OK. So a small PLC simulator will appear here, which is not in the run mode because the LED indicator is in orange mode. It is compiling. So it will ask me to load the program into the PLC simulator. So change this option from no action to start module and press finish. So as you press finish button, so observe this orange color LED turns into green. So now minimize the PLC and go into the monitor mode. Okay, now we are into the monitor mode. I will just minimize all the buttons here. Okay, I will open the factory IO software and I will split the screen so we will get better understanding. Okay, let's verify the output. Whenever I press first I will go to run mode. Whenever I press start push button, the inlet valve is on. Just observe the program in the TIA portal. Okay, the inlet valve is on. Okay, as the water level reaches the high level sensor, means this network should turn on. The inlet valve should turn off because we have given interlocking system here, and the outlet valve should turn on. Okay, the outlet valve has turned on and the inlet valve has turned off. So as you can see, network 5 is the interlock for network 4, and as the water level reaches the low level sensor, okay, this will activate now. As a low level sensor is sensed, the inlet valve should turn on. The process should continue now. Okay, as the water level reached the low level sensor, the inlet valve has turned on and the process continued. So this process should continue until you press stop push button from here. Okay, and the process should continue when you press start push button again. So this is what the basic water level system we have done in the programming. Okay, I will turn off the monitor mode from here. So this is the basic project we have created, and we have verified the output according to the program. In the upcoming videos, we'll see some more new concepts in the easy way. So take care. Have a nice day.